So I'm going counterclockwise around this figure. So I'm going to label it 1, 2, 3, 4, 5. Because we turn angles to the right with equipment, right? So that's why I always go counterclockwise. So my first angle at point number 1, if this will show up, point number 1 is 90 degrees, 47 minutes, 09 seconds. And I'm just going to follow it all the way down. 1, 2, 3, 4, 5. 104, 52, 08. Now this is all coming from that figure that I gave you guys. And then my last angle is 128, 23, 59. Alright, so all these angles, I want someone to take and sum them up for me down here on the bottom. Add all those angles up and tell me what we have for the sum of our measured interior angles.
I got my paper. Yeah. I'm missing that paper. Got the other paper.
I think I could probably help you out.
540 degrees, 0 minutes,
540 degrees, 0 minutes. What was it? 43 seconds. Okay. So we have 43 seconds of error.
I second that.
Now, how do we? Let's talk about how we distribute that error, because it's not going to go evenly amongst each of those angles, right? So if we had 45 seconds of error, we could evenly distribute 9 seconds to each angle. So this is one of those things where it's sort of up to you how you want to do it. So the way I do it when I distribute the amount of error is, let me write down how much error we have here, so that way. And that's a positive, right? So we're going to have to take it away in there. So my adjustment per angle, I could do it as a decimal, but I don't really want to do that because we're working with whole seconds, right? So my adjustment per angle, the way I tackle it, is basically go odd, even, odd. So I'm going to go 0 degrees, 0 minutes, 0.9 seconds, 0 degrees, 0 minutes, 0.8 seconds, and continue that pattern. So that's the pattern that I continue. That's what I choose to do. Maybe you had an angle that you turned out in the field on your traverse point that you felt was not a great one, and maybe you want to add the error around that angle for 2 points that were connected to that one angle. So, but this is the way that I do it. I just distribute it evenly. Okay, so can anybody tell me what our adjusted angles are then?
Well, the first one's 90 degrees, 47 minutes, 18 seconds.
Okay, so the one thing that I didn't write on here, I was hoping someone would say, we want to put negative in here, right?
Oh, yeah.
Because we're going to be subtracting those.
Ball seconds. 90 degrees, 47 minutes, 0, 0.
I was hoping someone would let me know that. So it's 90 degrees, 47 minutes, 0, 0 seconds. Now make sure when you're displaying angles, or even anything that has degrees, minutes, and seconds in it, that you're putting leading zeros. Or if it comes out to be 90 degrees, 47 minutes like this, put the 0, 0 seconds on there. Reason being, if we're recording these measurements in a legal document, it could leave room for interpretation on whether, if it was 1 second and you didn't put the leading 0 in front of it, they could think that if you just put the 1, they could think, well, that they forgot to put the 0. Make sure that you put the right information in there. Leading zeros are a big thing. Following zeros are a big thing. Don't forget those. How about my interior adjusted angle for number 2? Anybody have that one? 104.52.00. Okay. You can just shout them as we go. 3, 4, and 5. You have them?
108 degrees. 14 minutes. 56 seconds.
Okay.
107 degrees. 42 minutes. 14 seconds.
All right.
128 degrees.
You're on the ball here.
23 minutes. 50 seconds. Let's just subtract the neighbor.
All right. So now, just for a check, can we sum those up to make sure that we went the right way with our calculations? Hopefully, if they're summed up correctly, or if we went the right way, we should be coming out with 540, right? So we used this particular formula down here to solve what we needed to come out to be, and that was should have been 540, and that's what we now came out to have here. So we're good. Our interior angles are now adjusted. Now we can move on to the next step, step 2, and that's calculating the preliminary bearings, or azimuths. We're going to do bearings, so that seems like that's what most people are struggling with. So we have our figure again. You guys all have it sitting in front of you. All right, this figure here. But now when we calculate our preliminary bearings, we're going to use our new adjusted angles. So all these angles get wiped out now because they're not our adjusted ones. Those were the raw angles. So I'm going to quick write our adjusted angles on here. That way I know I'm working with the correct angles. Okay, so I have all my adjusted angles on our figure now, so that way I don't make a mistake and take the wrong angle off the figure. Okay, so we're going to be calculating bearings from these angles. Well, the nice thing is, well, let's lay this out first. So on this sheet, the computation of preliminary bearings or azimuths, my point, this actually should be line here. So I'm going to go from line 1 to 2, 2 to 3, 3 to 4, 4 to 5, and then back 5 to 1. Okay, so I'm working my way around this figure, going 1 to 2 is the first bearing, 2 to 3, 3 to 4, 4 to 5, and then 5 back to 1. So we're going to figure out those bearings. So the first one, we want to find out 1 to 2. Well, that one, pretty easy, right? Because that's the given. So our bearing there is north. Well, it's not a north bearing though. We're going from 1 to 2, so we got to flop that. So it's south 64 degrees, 14 minutes, 26 seconds east. southeast bearing. Okay? So now when we figure out from 2 to 3, which is the next bearing we're going to put in there, we want to take and draw our cross here so that way we know what direction we're heading with our bearing out. So remember when you're doing your calculating your bearing, that you want to probably turn your bearing, the bearing that's given, or your back bearing, into an azimuth and work with it from that. Okay? It's a lot easier to work with azimuths than bearings because you don't have to think about the directions you're traveling. So for this one, I'm going to leave this bearing, I'm going to use it as a northwest, right? Because we're heading this way around our figure. So this is my back bearing, or back azimuth. So I want to turn this into a back azimuth. So essentially, what I'm going to do is take
270 plus
360
minus 64.
Yeah.
1426, and that's going to give me my back azimuth. Okay, and then I'll just add the 104.52 to it, and it's going to be over 360, but then I can just subtract 360, and that'll give me my forward azimuth. Okay, that'll give me my forward azimuth here. So who wants to give me our forward azimuth here?
Why wouldn't you just
Or you can
subtract
do
64?
you can do that too. It's the way my mind works. Go ahead, what is it? 40, 37, 34 east, right? Or an azimuth, the azimuth is 40 degrees, 37 minutes, 34 seconds. That's the azimuth. Okay, so we'll record that in the line next to 2 to 3. North, 40 degrees, 37 minutes, 34 seconds. East. I want to put the azimuth out on the side here. Okay. So who wants to do the calculations for the azimuth from 3 to 4? Okay, so we're going to need the back azimuth of 3 to 2. Oops, sorry. Back azimuth of 3 to 2. So basically add 180 to this. It's going to give you your back azimuth 3 to 2. And then add the 108. 1456 to it, and that'll give you your forward azimuth, which then will have to be figured out as a bearing. So this is the forward azimuth, and this is and the back azimuth is 220, 37, 34 back azimuth. Okay. So we'll just take 220, 34, or 37, 34 plus 108, 1456, and that should give us our forward azimuth of the next call from 3 to 4. Keep spelling it wrong. Anybody have it yet? Anybody put Skylar? Wow. Furiously calculate with your calculators. The reason why I don't bring them on computers is I'd be standing out there doing it all the time myself. question, aren't you? You have it.
I think I got it.
You can give me the azimuth first if you want.
Ooh, azimuth.
Yep, you can give me the forward azimuth if you want first.
Is that 328, 52, 30?
Sounds about right to me. So the forward azimuth, from what Josh said, is 328 degrees, 52 minutes, 30 seconds. That's the forward azimuth.
Really?
You bet.
Did you do it correct?
All right, so what is our bearing there then?
I get north 310730 west.
North 31 degrees,
Yeah.
07 minutes, 30
30 seconds west.
west. Okay.
Do you agree with that?
Do people agree with that? Okay. So then what is our back azimuth then? Because, I should probably write that in on our sheet. Let's get that on our sheet quick. So we have a north 31 degrees, 07 minutes, 30 seconds west, and that azimuth was 328, 52, 30. Okay. So we have to now figure out our bearing and azimuth from 4 to 5. So what's our back azimuth then from 4 to 3? Because we're going to need to know that in order to figure out our azimuth from 4 to 5. Okay. So our back azimuth is just the forward azimuth minus 180.
148 degrees, 52 minutes, 30 seconds.
148 degrees, 52 minutes, 30 seconds, and that's back azimuth. Okay? So now we can just add 107, 42, 14 to that, and that'll give us our forward azimuth for 4 to 5. Hey Sam, do you see more baseball? Just a stretch, but it was good.
Damn good stuff.
All right, forward azimuth. Anybody? What'd you say?
You said from 45?
From 4 to 5, we're looking for the forward azimuth.
256 degrees, 34 minutes, 44 seconds.
Second.
256, and Skylar seconds it. 34, 44?
Yep.
Okay, that's our forward azimuth. What's our bearing there then?
South 76 degrees, 34 minutes, 44 seconds.
So 76 degrees, 34 minutes, 44 seconds west. How'd you get that? Bearing.
Subtracted the azimuth by 180.
Yeah, you subtract your 180 from the azimuth. Okay. So that's our bearing there. From 4 to 5. South 76 degrees. 34 minutes. 44 seconds. West. Our forward azimuth. 256. 34. 44. All right, the last one. 5 to 1. That's not your odds. It's number 5 to number 1. We're going to have to figure out our back azimuth again, right? So that's pretty easy because we sort of figured that out already. So we have a southwest bearing there. If we flop that bearing, it's a northeast bearing. Northeast 76, 34, 44. We know that anything in the northeast quadrant, the azimuth of the northeast bearing is exactly what the degrees, minutes, and seconds of that northeast bearing are. So that would be the azimuth. So we know that it's 76 degrees, 34 minutes, 44 seconds for the back azimuth, from 5 to 4. That's the back azimuth. The forward azimuth is 4 to 5. So now we know that, we can just take 76, 34, 44 plus 128, 30, or 23, 50, and that should give us our forward azimuth for the line 5 to 1. What's that one? 204, 58,
34?
34?
204, 58, 34. That's right now.
I must be dyslexic because I wrote the wrong number in my notes. Nice. Let's fix that one. Okay. So I'm going to record that up here then. Oh, what's the bearing?
24 degrees, 58 minutes, 34 seconds. At minus 180.
Yep. What is that bearing though? What direction is that heading?
Southwest.
Yep, southwest. So south.
Oh. South 24 degrees, 58 minutes, 34 seconds west.
Very good. Okay. We figured them all out.
Howard, I think the azimuth from 4 to 5 is wrong.
4 to 5. Okay. Let's check it out.
That was great.
Because I did. Our bearing from 3 to 4 is 31 degrees, 07 minutes, 30 seconds.
Mm-hmm.
And 180 minus that, plus our interior angle is 256, 34, 52.
Do you have the wrong angle, interior angle right now?
14.
107, 42, 14.
14
I looked
plus
at the wrong
30.
one.
14 plus 30. So, we're good. Thanks, Josh, for checking that though.
Awesome.
I'm checking my wrong
Can anybody tell me what the azimuth then of 1 to 2 is? Because we never figured out the azimuth from 1 to 2.
I thought it was,
I want the forward azimuth.
well, you know, 20 south, 24, 58, 34
That's the
west.
bearing.
That's the bearing. So I want the azimuth. So 180 minus 64, 14, 26.
You took 180 from where?
So southeast bearing, that angle is from the south line, the north-south line.
From 1 to 2?
1 to 2.
I would say 154 degrees. Does that sound right?
Nope.
115 degrees, 5 minutes, 34 seconds.
115 degrees. 115 degrees, what did you say?
45 minutes, 34 seconds.
There we go. Start on.
Anybody concur with that? Yes.
Do we need to break down the azimuth for this?
No, you don't. I'm writing them down. So Some people think it's better in azimuths than bearings. So I would caution you all because what I saw on that test for civil public works was there's a lot of people that were confused at bearings because they were trying to just work in bearings. So it doesn't hurt, it's one extra step. It doesn't hurt to check, to go to azimuths first and then go to bearings. If you notice, as we went around this whole thing, I had you figure out in azimuths, but you notice how easy it was to think about which way you had to go when you had the azimuth already figured out. Just all you're doing is adding. Well, if you have bearings, now you got to think about what side of the axis you're on and which way to subtract and stuff. So it's a lot easier to work in azimuths along the way. All right, so now we can move on to step 3 of this compass rule adjustment. We have all of our bearings figured out. It'll be unadjusted latitude and departures will be the next page that we're going to move on to. The unadjusted latitudes and departures, and this is where hopefully this will clear some stuff up for you guys. Okay? So on this sheet, if you notice, the last sheet I gave you, number 4, the big sheet, if you look at the both of them, which I can't really zoom out too well, but I have point, azimuth, length, latitude, departure. If you look at the big sheet I handed to you, it has the same thing. Point, azimuth, length, latitude, departure. It's the very first part of it. Okay? So we're going to figure it out on here just so I don't end up confusing you too much. This is just like an interim step. We're going to end up copying all the stuff we do here onto the big sheet once we get the big sheet all figured out, or the small sheet all figured out. Okay? Just want to keep it so that way no one gets confused. Now, the thing to remember when doing a compass rule adjustment, which is what we're getting ready to do, this unadjusted latitudes and departures, the way you set up this sheet, there's a systematic way of the reason why I'm doing this, setting it up the way I am. So, as I label my numbers on here for my points that are going around our figure, 1 through 5, I want to skip a line. Okay? So I'm going to start 1 here, skip a line, go 2, and keep that process going all the way down and come back around to number 1. You'll see why I do that here in a little bit as we populate data in here. All right. Here we go. So we're gonna put our preliminary bearings in here that we already figured out. So from 1 to 2 we have a bearing. Here's why I skipped the line. We're gonna put the bearing between them because they are 1 and 2 form that line with the bearing on it. So I'm gonna put the bearing between it. South, 64 degrees, 14 minutes, 26 seconds. East. I'll go down 2 to 3 was what bearing? And
North 40 degrees, 37 minutes, 34 seconds.
34 seconds. East. How about 3 to 4?
North 31, 07 minutes, 30 seconds west.
4 to 5.
South 76 degrees, 34 minutes, 44 seconds west.
And then 5 to 1.
South 24 degrees, 58 minutes, 34 seconds west.
Okay, so we labeled our bearings that make up the lines. So we label it between because they're a portion of the line that connects those 2 points. Okay, now we have to pull our lengths here. The distance is off of our figure. This figure here, again, because we keep going back to it. So my distance from 1 to 2 Looks like 2017, 2000.17. So I'm going to label that next to it also. Now I'm just going to go around the figure right from the map and pull all of them off there. It's 1655.15. Oop. And then 1487.32. 1546.34. And then the last one, 1435.00. Boy, those surveyors were good, man. They got
Right on.
exactly a whole foot when they were out there. That's impressive. They were probably stringing steel tape too. So, alright, so what's our next step?
Find the difference in,
I'm going to switch to red.
or the change in
Or green.
and the change in departure.
Alright, so we're going to figure out the change in latitude and departure. Who can tell me what the formula is for change in latitude?
The sign of the
Boy, that marker is not good. We're going to move to a pen.
Change in latitude. Yeah.
Change in latitude equals cosine.
Yep.
Oh, it's just, that's the angle, but I say angle, but times distance. Okay, that's change in latitude. How about change in departure?
sign of bearing times distance.
Sine the bearing times the distance. Okay, so that's the change in departure. So for the first one then, from 1 to 2, let's figure that out. So we'll take and figure out our change in latitude. So latitude, change, departure. Remember, latitude is the northing, departure is the easting. Pythagorean theorem, right? If we were given the latitude and departure, we should be able to figure out that bearing pretty easily. Or the distance of that bearing, anyway. So let's calculate that for... Someone give me the latitude for number... Change in latitude for number 1.
869 point
Bring it out to 4 decimals for me.
2613.
So it is 869.2613.
Would you?
Negative or positive? How do we know?
That's going to be a negative
Be negative y.
because we're going in a south direction.
Exactly, right. Going south. Going south. So that should be a negative. The signs are extremely important in this step. We need to make sure we keep the signs there, or else if you don't put them there, everything's going to go kittywampus on you, and it will not be a good situation. Yes, sir.
I'm pretty sure if you use the azimuth, it gives you a negative or positive.
Try it. I don't know. I've never used azimuth in this calculation. I've always
Because
used
it would tell me a
Sweet.
negative or a positive straight up.
use your azimuth.
Well, I didn't write it down.
Well, here's the part I'm not telling you yet. So you guys are going to go through all this calculation and everything, and next week you're going to have to bring your field book in so you can do your thing that your figure that you did this fall on campus. You're going to have to adjust that baby. But after you get done hand adjusting it, you're going to take and make an Excel sheet that does the calculations for you. That's the computer apps part, right? And I'll tell you right now, it's a pain in the rear end. So. And I know that last year most of our students ended up using azimuth instead of the bearing because they couldn't get the bearing to work. So, hint, hint.
That's because they're weak.
All right. Who wants to give me the change in departure for number 1 to 2? 1,801.4063. All right. Go ahead and spit out the next one. So what I did here, we're going to do here. Okay, change departure, change in latitude. For the next one, going to 3.
1,256. 2169.
Okay,
And 1,077.7015.
any of those negative?
Negative.
Negative. Okay, that's good. Why is that?
Is east and north.
Yep, both in the positive direction, right? That's why I drew this up here for you guys. So northeast is positive, positive. Southeast is negative, positive. Southwest is negative, negative. Northwest, positive, negative. Corner 3.
1,273.2078.
Okay,
Negative 768.8060.
okay. Number 4. From 4 to 5. What's the change in latitude and departure? 4 to 5. So we did the same thing here.
Negative 358.
Negative 358.
0.9153.
Okay.
And negative 1,504.1101.
All right. Next. Last one. So if you look, we've been doing this the whole time.
Negative 1,300.8044.
All right.
And negative 605.9149.
Does anybody concur with those measurements? I just want to make sure that those are the measurements that were our calculations that were coming out. I don't want to just run with one. Everybody's got the negatives and positives, right? It's a little easier to think of when you look at drawing out these lines on there.
I think
Like
I did
this?
that on my old test.
Yep, so change in departure, change in latitude, right? So as you can think of it that way. I mean, I could have drew it in here too. It doesn't really matter. It's a square, right? So, or a rectangle. So it's pretty systematic how we were doing that. All right, let's figure out our linear misclosure. So down here on the bottom, we need to figure out our linear misclosure. So why don't we take and let's sum up the external distance of our figure, and then take and sum our changes in latitude and changes in departure. Let's populate those down here on the bottom. So whenever someone gets the length figured out, you can go ahead and shout it, and I'll get it populated on here.
$8,123.98 feet.
All right. Anybody concur with that?
Okay. I got the next one.
Oh, Sam's got it.
Sam's on the ball today.
Good
All
job, no one cares.
right, change in latitude.
0.4437 and then 0.2768.
All right. Now, were those positive or negative?
Both were positive.
Both were positive. Okay. Signs there also are important. And you'll see why in our next step. So, make sure you label the signs there. If there's a negative, make sure you put it there because it's going to be very, very important in the next step we're going to go to. So let's figure out our linear misclosure then. So let's just Pythagorean theorem.
Hey.
So square root of 0.2768 squared plus 0.4437 squared. And that will give you
0.522, 0.5230.
so that's our linear misclosure.
So we're 5/10?
5/10 off.
No, 2/10 off.
Or, no, we're 5/10 off. 5/10, oh, sorry,
Yeah, 5,200, yeah.
5,200.
Right, gotcha.
Half a foot off and 8,000 feet.
6 inches.
Or 1 in 16,000. But we're going to figure that out right now exactly what we are. So, alright, so now that I found this linear of our figure, how good we did, right? Before our adjustment. So, relative precision is our linear misclosure over our total length. That's why I had to figure out that number right there. So it's 0.5230 over 8123.98. What is our relative precision?
1 over 0.00006437. Yeah,
Oh,
that's what I got.
Okay, take the inverse of that, and that's going to give me the number I'm looking for.
I'm looking for total length over this closure.
Well, you can do it that way too. Take the inverse of that. 1 foot in how many feet? Can I be off? That number you just came up with, take the inverse of it. You don't have the inverse symbol on your thing?
I mean, I have 15,533.
There you go.
Over 2,
That's what I'm looking for.
2, 6.
Okay, 15,000.
15,533.
That's good enough. We don't have to do the point. So we are, basically our precision is, for every 15,533 feet we travel, we're going to be off by 1 foot. What's the state standard for Wisconsin?
1 in 3,000.
This
This is how the book tells us to do it?
Yeah.
But how
You
would
can,
it
yeah.
wants it?
This is the way the book shows out.
Yeah.
I always,
So how do you think it is?
practical sense.
Well, just
Put the total length over.
Flip the value?
But just, yeah, flip the value. So just do this over that.
No, you won't. I mean, you'll get an answer, but it's the inverse of it, right? So you have to take the inverse of it.
I
You
think
get the
it's
right answer.
inverse.
Because the book is just, trying to make money.
That's right.
They'll make another version and be like, oh.
Okay, so now we figured that out on number 3 here. We're ready to move on to our actual compass rule adjustment. And this is where the real nuts and bolts come together for figuring out our traverse to make sure it's really a good, nice, tight traverse to use when we go to collect data, like say a highway project or something like that. So now, why don't we take like a 10-minute break, and when you guys when we come back, we'll have this all copied. All of number 3, all this data, has to go onto the main sheet here. Okay, take a 10-minute break, and you guys can work on populating that while we take a small break here. We ready to rock and roll again? Okay, so I have the big sheet now, the compass rule adjustment sheet. It's also known as a Bowditch adjustment. That's the gentleman that figured out that you can adjust the traffic this way.
That's a sweet last name.
So, it's a Bowditch adjustment.
Where you go, Hunter?
So, if you look at this sheet, it has all the same columns as the others, or the other ones that I showed you. So, we're just going to extend this now. So, what we just got done doing, and all this stuff that we did, was adjust the angle.
But you just have to hit one more button.
Now we have to adjust the distance problem.
So it could mess with you.
We know that we're off by half a foot in distance, right? Because we figured out our linear misclosure as being 0.5230. So that's how far off in distance we are. Our angles are right on now, right? They summed up to be 540. Now we want our distances to come out so they are even. So that's what we're going to do in the rest of this nice little thing here. All right, so down on the bottom of this sheet that I have here, you're going to see some more stuff, more calculation or formulas. So this is the linear misclosure, which we already figured out. That linear misclosure was 0.5230, and our relative precision was 1 in 15,533 from that other sheet. This is just being transferred from the other sheet. Okay, so we figured out these two things. Now we're going to have to do an adjustment to our raw or unadjusted latitudes and departures to adjust for these errors. Because if we sum up our latitudes and we sum up our departures, both of them should, if it was an adjusted traverse, to be 0. So that's what we're going to try to do. That's what we're going to try to achieve right now with these calculations. So if you look at these formulas we have down here, so the correction in departure is the total departure misclosure divided by the traverse perimeter times the length of the segment. So we're basically doing a proportion for each one. Okay? Same thing for the latitude. Same formula, but you're using latitude misclosure. So one thing I want to caution you of, and I did it myself when I was going through the practice problem for this, it's very easy when you're doing this calculation to plug in one of these numbers. You don't want to plug in these numbers, the latitude or change in latitude or departure. You're wanting to plug in the length. Okay, it specifically says traverse perimeter, which is the perimeter here. Okay, and then the length of the segment is the length, not the departure or the latitude. It's the length. Okay, very easy thing to do to make that mistake. All right, so here there's a rule here that we need to know. So once we do these calculations down here on the bottom, if I can get them to show, I'm working backwards here. Okay, these calculations down here on the bottom, there's a rule. Our change in latitude and departure right now is positive, right? So that means we're over the amount of distance we need. So we have to make it a negative when we put it back into the equation. All right. So we have to take away. We want to make these so they're taking away from our latitudes and departures. So let's do the correction in latitude first. We'll populate all the corrections in latitude first, and then we'll do the departures. So the first one, I should probably grab a piece of scrap paper here. So our first one, if I go with this formula here, and I drag, let's see here, we're total departure misclosure, well, latitude, we'll do latitudes first because that's the first one that shows up. So total latitude misclosure, so that's 0.4437. So 0.4437 over the perimeter of the traverse, which was 8,123.98 times the length of the line of the segment. It's 2,000.17. What is our adjustment for this first one? So it's 0.0 what is it?
1092.
0.1092. All right, that doesn't seem right. Oh yeah, no, that's right. Never mind. Okay, so and Skylar said it's a negative, right? Because we're taking away now because we have a positive down here. So this is a negative. So what I'm going to do with this number is I'm going to put it right underneath it. I'm going to put it in parentheses. Negative 0.1092. The importance of this you'll see in a second. Why we're doing that. Let's go ahead and go out through all the latitudes, and I'll have you guys give me. You're going to do this calculation for each one of these. So all you're doing is changing the distance on each one. And I'll write them down on here, and then I'll let you know what we're going to do next. Okay? So this next one, 0.4437 divided by 8123.98 times 1655.15 equals all right, so anybody have numbers for me?
Negative.
869.
That's for number 2 to 3?
3. 1,256.1269.
No, I don't want you to subtract it yet. I want the difference, the change, how much we have to do, how much we have to change there. 0.0904. How about the next one?
0.0812.
Okay.
0.0845. 0.0784.
Okay. I'm going to put them all up here. Negative 0.0904. Negative 0.0812. Negative 0.0845. And negative 0.0784. Now, Sam was working a little bit ahead there. So what we're going to want to do, we can figure out our balanced latitudes now based off of these numbers. Okay, so if I want to figure out my balanced latitude, I'm basically going to take, because this one's a negative, right? My unadjusted's a negative, and I'm subtracting, you're basically adding. But it's going to stay a negative. So it's going to be a negative 869 point. Don't have a calculator.
1521.
No.
0.3705.
3705. Okay? You subtracted. Yeah, if you're subtracting from a negative, it's adding. So.
The two lines make a plus.
Okay, so let's go ahead and we'll populate all the changes, or all the latitudes that have changed there, and then we'll go back to the departures and we'll do the departures. Okay, so the next change in latitude for the balanced latitude would be 1256.2169 minus 0.0904, or plus a negative. 1256 point
1265.
1265. Okay? And then the balanced change in latitude from 3 to 4 is going to be 1273.2078 plus a negative 0.0812. What do we get there?
1273.1266.
1237.1266.
0.1266.
Oh, I wrote that one down wrong.
All right, how about the next one?
Negative 358.9998.
Wow.
Negative 1300.8828.
Cool. All right, so we have all of our adjusted latitudes, our balanced latitudes on there. Let's take this one more step before we move on to the departures. Add up all the changes in latitude for the balanced changes. Let's see if we did our math correctly. So sum them up. They should come out to be 0. Might be off by a little bit by rounding, just depending on how you guys rounded. But it'll be off in the 10,000ths. So we just want to be out zeros out to it. So what is the sum of our balanced latitudes?
Come on, Sam.
0.
It is 0? What is it? Does it come out exactly 0?
I got exactly 0, yeah.
All right, cool. So there's a check for us. We did the right math because it comes out to 0. Built-in check. Okay, there's a couple of these throughout the process. All right, so now let's figure out the correction in departure for the unadjusted departures. So that is same thing we did with the latitude, but we're going to have the departure. So 0.2768 divided by the total length, 8123.98 times the segment length, 2000.17. What's that one going to be? And we can just go all the way down.
0.0681. Negative.
And it's a negative. Very good. As you guys get these, you can fire them off and I'll write them down.
0.0564.
Negative.
Negative. Negative 0.0507. Negative 0.0527. I don't know that one.
Okay.
Which one?
The last one.
Negative 0.0489.
Yeah.
Okay. So this one here is negative 0.0681, negative 0.0564, negative 0.0507, negative 0.0527, and then negative 0.48. Oh. 0.0489. It's a negative. Okay. Based on this information here now, we can figure out our balanced departures. Okay? Balanced departures. So 1801.4063 plus a negative 0.0681 should give us our balanced change in departure. So as you guys get those, go ahead and let me know.
1801.3382.
3382.
Yep.
Okay.
1077.6451.
Okay.
Negative 768.8567.
All right.
Negative 1,504.1628.
All right.
And negative 605.963.
All right. So let's the sum of our departures now should also equal 0. So someone take and sum the departures up of our balanced departures, and they should equal 0. If it does, we successfully took out the distance error in our traverse, and then we can move on to calculating balanced coordinates for each point, which in turn will allow us to balance out or figure out balanced bearings and balanced distances. And then we just perform a compass rule adjustment. So what is the sum of our departures? It's 0. Good. Means we did something right. Okay? So 0. So this is our check. We did the math correctly. If these are 0, we're good to move on. Now, if you get 0.0001, you can count that as being balanced. That's often the 10,000ths place. You can measure to the 1,000th, but not to the 10,000ths. What that means is you had some type of, you rounded too many times even, or rounded up too many times is all that really is. So it doesn't mean a whole ton.
Probably we're gonna go with 4.
Yep. All right, so how are we going to get our coordinates now? So we got to the point now where we can calculate some coordinates. I'm going to move this over. All right. Well, in the figure we were given, if I can scratch it up here, in this figure that we were given, they give us the coordinates of number 1. All right, so 1,000, northing is 1,000, easting is 1,000. So we can use that. Now here's where organization comes in again. So coordinates, all the stuff we figured out right now had to do with the line, right? The line between the points. So now when we figure out coordinates are a value that are at that point. So we want to make sure that we write them across from the point. So from our figure they gave us number 1 is 1,000, 1,000. So 1,000, 1,000. I'm going to go up 4 zeros because we have all these out to 4 decimals. Okay? So all the numbers we figure out from here on out, we're going to put across from the point number for coordinates. Alright, so now, if you look at, we have our starting coordinates, and we just figured out our balanced latitudes and departures. It's as easy as adding now, at this point. Okay, so our signs are preserving our direction. Gotta make sure you keep the signs. So our latitude, all we have to do here is add negative 869.3705 to 1,000. And that's going to give us the northing for point number 2. Okay? So what should that be?
130.6295.
130.6. What was that?
Oh, 6295.
95. Okay? Same thing for our easting. We're going to take our balanced departure and add it to our easting. Which is what? That 2801.3382. So there's the coordinates of point number 2. Now, we can't add them to number 1 every time.
No.
We have to jump to the next point, right? Because we're going from one point to the other. So, to get the coordinates for number 3, we need to add our changes in latitude and departure to the coordinates at number 2. Okay? That's an easy mistake to make, is just to keep adding them to number 1. But we're moving through the traverse. If you look at our figure, we're moving through the traverse, so we're computing coordinates at each one of those. So once you get number 3's coordinates, let me know. 1386.7560. 1386.7560. Anybody concur with that?
7560.
Okay. How about the change in, or the easting coordinate for number 3?
I have all the northern if you want though. It's easier if you just go online. You don't have to-
It's true. We can do that. Give me the northern of 4 then.
2,659.8826.
Okay.
2,300.8828.
300.8828.
And 1,000.0000.
1,000. We went back to point number 1, right? So as we were going through adding our changes in latitude, when we came back to point number 1, our check is that it came back to 1,000, the same coordinate that was started at. So this is a check. If that didn't work, it means we did our maths wrong somewhere. So these are inherent checks that you'll have. So when we give you your homework problem on this, and you start doing it, if you don't check at this point, go back and check your math. Don't get frustrated. Go back and check your math. Okay? Same thing with the test. When I give you the test for this, you're going to have something very similar to this that you're going to have to do for a test. Use your checks. Know your checks. All right, so let's finish out the easting then.
3878.9833.
Okay?
3,110.1266.
So we're taking in the 3,110.1266 minus the 1504.
1605.9638.
Okay, here we go for our check again. So this minus this is 1,000. And that checks. So there's our other check. All right, so we did our math right all the way through. Fantastic. Now, who remembers how to calculate a bearing?
It's
The arc tangent of the departure over the latitude.
yeah.
Oh, you're a math guy. What do they go by now? Inverse tangent, arc tangent? All the same, right?
It's
I say arc tangent, I must be old school because everybody goes by tangent inverse or whatever now.
It's second tangent. That's what it is.
Second tangent.
Using the word tangent, not tangent.
So, all right, so let's figure out the bearing then at from number 1 to 2. Now, we're going to populate the bearing in between, can't really see it, in between 1 and 2 because it's the line of 1 and 2 again. So we're going to populate that between. All right? So now we use our balanced latitude, and departure to figure out that bearing, because the bearing is going to change now from the original bearing we figured out. So when someone gets it, let me know what that bearing is. Pay attention to your signs for the direction that bearing is heading.
South 62 degrees, 14 minutes, 13 seconds east.
14 what? How many east?
2 minutes, 13 seconds.
13 seconds east. All right. And we have a concur on that one. So we're using the tangent, or arc tangent of the departure over the latitude. Okay? And this is for the balanced departure and latitude. Okay? Now, we know that it's southeast, right? Because the change in latitude is negative, so you're heading south. And the change in departure is positive, so you're heading easterly. So we know that the bearings is southeast. It will not be exactly the same as with the bearing. I mean, the direction will be the same as the bearing before, yes.
Unless it's like right on 90.
Yeah, which doesn't happen very often. Yeah. All right, so give me the bearing between 2 and 3.
North, 40 degrees, 37 minutes, 36 seconds east.
All right. Notice how we're changing by a couple degrees here and there. It depends on where that error was or what direction that error was. So some of our bearings will have more error distributed to them. It's okay. Okay, so I take my arc tangent or tangent inverse of the departure over the latitude, and it should give me the bearing between 3 and 4. What is the bearing between 3 and 4?
North, 31 degrees, 07 minutes, 42 seconds west.
Yep, because you're going positive in the north and negative in the easting, so you're going northwest. Next one. Both of them have the negative sign, so what's that tell me? It's southwest.
Southwest, 76 degrees, 34.
Oh, 76. I wrote 78. 34.
4 minutes, 35 seconds.
Okay. And then our last one. Heading back to our original point, number 1.
Southwest again.
South. Okay, so it's a southwest again.
Southwest, 24 degrees, 58 minutes, 36 seconds.
Southwest. All right, so we got our balanced bearings. There's no real check we can do there because we already did the checks along the way. Besides, there's one check you could do, and you could figure out the interior angles that are made by each of those. You could do that, and then you could take and do the n minus 2 times 180, which is 540, and then those should all add up to being that.
Yeah, I'm satisfied.
Well, if you've already done 18 different corrections, I'm sure they're pretty damn.
You never know.
18? It was 18.
You never know. All right, so let's figure out our distance now, our corrected distance, right? Our distances are wrong. We had our balanced angles. Now we want to figure out our balanced distances. So how do you figure out the distances now?
You take very carefully.
Pythagorean theorem. Yep. Change in latitude squared plus change in departure squared. Or you take the square root of it. Of the latitude squared plus the departure squared.
Of it all.
So then once you get those guys,
Yeah. That's a lot of buttons.
Yep.
How many decimal places for the line?
All of them.
the Hunter's place now. Okay. So we started out with our distances to the 100th that were given to us in the 100th. We should display them to the 100th of a foot.
2,000.16.
2,000.16.
Feet.
That's feet.
Oh, I don't like, 'cause I didn't do this.
I'm sorry. Say all that one more time. Get the distance.
Get the distance. It's the distance
Yep.
equals the square root of the departure squared plus the latitude squared. The change in those.
Balanced ones, right?
The balanced ones. These are the balanced ones, yes.
Second one is 1655.04 feet.
Yep.
Keep it going.
I could be really cruel and ask you guys to figure out the area too, real quick.
Oh,
The area is figured.
that's actually simple.
Third one is 1487.28.
Okay. 1487.28 is the distance from 3 to... How about the distance from 4 to 5?
$2,300.
Ooh.
1546.41.
1546.41.
Yeah,
All right.
forgot to take the square root.
And the last one. Back from 5 back to our starting point, number 1.
1435.09.
1435.09. What was that, Jim?
I don't think that's right.
1487.
1487.28.
I think the last one's 1,300.
No, it's not.
Oh, I got 14.
Oh,
Alright.
1435.09. So it should be close to 1435. That's what the original measurement was. We didn't take that much away. The original measurement was 1435 even. So
Man, that took more than that.
I got
Sweet.
Yep, I got that.
1435.09.
Yeah.
All right. So we just successfully completed a compass rule adjustment on our traverse.
without a compass.
Without a compass, yeah. Yeah, by hand. So next week, when you guys come back in,
We're doing it on the computer.
you're gonna bring your field book with you from the field exercise we did this fall. For those of you that were not in here, everybody was in here this fall, right? Except for Jim.
I've got one.
Okay, so if you have it, bring it in. We're going to take that field exercise that we did right at the end of survey mapping last year,
It was cold.
which I think most of you balanced the angles on already.
Yeah.
So you're already one step ahead, but you're going to have to put it in one of these sheets. So what I'll do is, I think I might have this sheet on the blackboard, if you'll be able to print it. You're going to basically perform the compass rule adjustment on your figure that you guys made last fall. And I think I had you record a bearing down, so you're going to use that bearing as your basis of bearing. If you didn't do that with Rick, I will give you one. I'll give you a bearing.
I think he assumed one.
Okay. So, and we're going to go through and adjust our traverse that way. When we're done doing the long form, we'll call this the long form, then I will show you how to use Wolfpack to adjust also to check your answers. And then once you're done with Wolfpack, that's what's going to trigger you guys to have to sit down and try to make the Excel sheet
They got a wolf pack.
to work. Okay? So, chapter 10, those homework problems that you guys did on chapter 10, go back and revisit those.
Do we hand it?
Yeah, well, most of you did.